Good afternoon and dzień dobry. Welcome back to Visualizing Operational Informatics Data using R. This is a hands-on tutorial on Shiny Dashboard package for R. By now you should have installed R, RStudio, and packages Shiny, Shiny Dashboard, DevTools, and RCharts. You can use the listed commands or follow the instructions to install these packages from source provided on the flash drives. For this tutorial, we use an R file called Hands-on Shiny Dashboard FD. It has some starter code for the tutorial and also some dummy data in a CSV file. Step 0. Run the provided R code. As you can see, I am now in the Hands-on Shiny Dashboard FD file in my RStudio. You can see that the starter code provided loads the necessary packages, reads in the dataset, and prepares the data for visualization. After the data preparation code, you can see some Shiny Dashboard objects. First is the UI, and then the server. You can see that the UI is created using the dashboard page function, which itself takes 3 functions as arguments: dashboard header, dashboard sidebar, and dashboard body. You may notice that dashboard page consists of functions, and those smaller functions take more functions as arguments, so you have to always remember to separate them with commas. The server is now an empty function with no body, but it takes 2 arguments, input and output. We will talk about those later. And then you have to provide UI and server objects as arguments to the Shiny app function to display the dashboard. Let's try to run all of this code, including the very beginning, where we load the libraries. If by now the run button has disappeared from your RStudio, you can use the combination of keys Ctrl-R to run the code. This opens the Shiny dashboard. You can view it in a browser. So if you open it in the browser, you actually see almost nothing. This is just an empty canvas that you will populate with charts and value boxes and all the other objects that you would want to see on your dashboard. This area on the top is the header. On the left side, you see the sidebar, and in the middle is the body. So going back to the R file, you would want to stop the display of the dashboard by clicking on this red stop button. Otherwise, if you don't, you won't be able to run another dashboard display. I would like to point out that normally if you build a Shiny dashboard, you would separate the UI code and the server code into 2 separate files. So in the UI file, you would type it like this, and in the server file, you would provide the Shiny server function in this way. However, for the purposes of this tutorial, to make it easier on the eye, so we don't have to switch between 2 files, we combine them into 1 file. You can remove these comments because we will be typing our code in this place. So step 1, let's add a title and a content box to the dashboard. Content boxes control the layout of the UI and can be used for text or to output a plot, a table, a value, or any other graphical object from the server side. We already prepared some charts in RCharts hands-on, so we'll use one of those in our first box. You can either copy the chart from your exercise file or from the solutions file provided. So let's work with the UI first. You would open the dashboard header function and add a new line and add the title here. You would type title equals my dashboard. Inside the dashboard body, we would like to add a single box for content. So you would add a new line, box. We will come back to this point later. Now inside the server side, we would like to create the graphical object that we will put in the box. So add some space here. Every graphical object that will be displayed on the UI is added to output. So you would type output $, and then the name of the graphical object you would like to display. So in our case, it would be HD tickets chart. And we will assign it the object created using render chart function. Notice how you have to supply parentheses and curly braces inside. That's where you will be putting the object information. In Shiny library, there are many render functions. You can use render plot, render text, render table. In this case, however, for the rCharts objects, we use render chart function. So inside the curly braces, we will copy and paste the chart code that we worked on earlier. I actually have the hands-on rCharts file open in my RStudio, so I will go ahead and copy from there. You will select only the chart-related code and paste it inside the render chart function. However, we're not done. We have to still connect the plot that we create inside the render chart function and the HD tickets chart object. For that purpose, we need to modify one of the attributes of the plot like we did earlier. We will add the $, and type add params. The attribute name is DOM, D-O-M, and we assign it the name of the chart, which is HD tickets chart. And the last line would be to return the plot, HD tickets plot. Going back to our UI object, we need to now supply the information about this chart inside the box. So you would type show output. You would type the name of the chart object, which is HD tickets chart, and then you would provide the name of the library that you used inside rCharts to create it. In our case, it was HiCharts library, so we provided in all lowercase inside quotations. And that's it. Now you would select all of this code, including the Shiny app function and all the way up to UI, and hit run, or I'm using the combination of Control-R on Windows. This just created our dashboard. You can open it in the browser to view it in a better way. So now you can see the box that is wrapped around our chart from the previous video. You can also see the tile that we just added, and if you would like to hide the sidebar, you can do that clicking on this button. Don't forget when you go back to the R file to stop the previous display. Step 2. Let's add an input widget. You can see the full list of Shiny widgets at this link, and in order to demonstrate a simple drop-down widget, we will also add another plot on the server side. It will take the input from the user and act dynamically on it. The user will select a grouping variable from the drop-down widget, and it will be used to group the number of projects or other tickets in our example. So going back to the UI part, let's add another content box beneath the one that we already have. Remember that we have to separate it with a comma. Inside that box, we'll have a drop-down widget. In Shiny terms, however, it's called a select input. It takes quite a number of arguments. The first one is input ID. We will call it group. Then the label that the user will actually see in the UI, we'll make it pretty, group by, colon, and some space. Then we want to provide the choices that the user will have to select from. We say choices equal a vector of what columns the user will be selecting between. So we have application column in the dataset, and we have the funding type. make sure that you provide these names just exactly as they are in the data that you will be selecting from. If you would like the names to be different from what the columns are named, you will actually have to use a labels argument. And then the last argument we want to provide is which of these two is selected by default, and that will be application. Well, we'll come back to this later. Now go to the server side and let's add a new plot object. As any output object, we have to start typing output, $, and what we will call it. Let's call it a frequency plot. We will assign it the result of render plot function, and the difference here is that because we will be using the base graphical package from R, we will be using render plot function instead of render chart. The user input will be provided to the server side through the input object. It's a list-like object, so to store it for the purposes of our plot, we will put it into this variable called group. I'm just calling it in all caps to separate it from other variables. We will call the input object and select the group. Remember how we called our input ID group? That's how you will reference it inside the server side. So when the user selects the column to group the data by, it will be stored in this group variable, and it's part of the input object. Now let's build our plot. We will call it fplot. We will use the base graphical library for R and just call plot. Inside ops data, we will only select the column that the user selected. So that column will be stored in the group variable in all caps, and that's what you provide in the square brackets. And then you provide the name of the plot that you would like to see, and we will call it number of tickets. So you say main equals number of tickets. And that's all. In order to display the plot, you would need to call it, and we call it using fplot. However, it's still not going to show up on our dashboard unless we display it inside the box. So let's go back to the same box where we added the widget, add a comma at the end, and on a new line we have to say plot output and the name of the plot, frequency plot, inside quotation marks. And if you would like to specify a certain height or width, you can do that here as well. So we specify 300 pixels. Now you can select all of this code starting from the UI and up until Shiny app. However, before we do that, let's wrap the Shiny app function into the run app function, which will force it to always launch into the browser. So you wrap it inside run app, add a comma, and the second argument is launch.browser equals true. So now if you run all of this code, it will automatically go into the browser. And voila, we have two charts in our dashboard, and this chart on the right is now going to be dynamically responsive to the user input. So this is the widget that we talked about, the drop-down menu, and we can select between application and funding type. If you select funding type, the chart will dynamically adjust. The last step, step 3, we have to create a reactive dataset. This dataset will also use input from the widget, and it will dynamically change based on the user input and can be reused in several charts or other graphical objects. Going back to RStudio, let's stop the current dashboard display. Let's go to the server side and create the reactive dataset. This is, however, not an output object, so you just go ahead and name it. We will call it filtered data, because essentially you're dynamically filtering data based on user input. We will assign it the result of a function called reactive. You create it the same way as you did render chart or render plot. Inside reactive, you will modify the data using some kind of user input. We will actually move some code from the frequency plot function. We will move out the group variable, and we will modify the data also inside the reactive dataset. So this is all that will go into filtered data. You create the variable based on user input again, and you modify the data based on that. You also have to make sure that you call the dataset, and this line right here will call the dataset. Now, instead of using that ops data with group selection inside the plot, we will call filtered data object, which is the dynamic dataset. However, because it is dynamic, it will look like a function, so don't forget to add empty parentheses behind filtered data. You don't have to change anything on the UI side. This will act just the same as the previous dashboard did. So let's select our code again from the end and up to the UI and click Run. You still have the same two charts. However, on the back end, you now have a reactive dataset that you could reuse in several dashboards. And that reactive dataset is controlled by this widget, the dropdown. At this point, you are now ready to add a chart and a widget to the dashboard on your own. We provide some data preparation code in the same file and the requirements to add a histogram chart and a widget to the dashboard. Please feel free to try this later. We'll post the solutions and the tutorial code on GitHub. This is it for this tutorial, and thank you so much for watching.